Hi everyone, welcome to another live stream with our founder Shashank. How are you today?
Yeah, I'm good. It's been a bit hectic with a lot of improvements coming on index. Our community members have already seen, like we continuously try to make it better, make sure their trades are more profitable, and yeah, just try to improve the experience.
Absolutely, you guys have been working amazing. You, our CTO, the dev team, and like, can you tell us a little bit about the, like improvements and the things that you gave more freedom to traders? Like now you can adjust, like the stop loss, the take profits, and maybe the wisdom behind that.
Yeah, first of all, I would say it's not just you guys. I mean, you guys have been doing well too. It wouldn't have been possible had you not gotten us so many users who have shared us with their feedback. Sometimes negative, sometimes positive, but that's all needed for a product to grow. So yeah, and yeah, it's because of that feedback that we have been able to make those quick changes. So the goal of the product is to make sure users can follow the best agents, identify how they're trading, and just take their trades on the basis of that. Sometimes you might not agree with the agent. Sometimes the agent might not be doing well in the recent past. So it's evident that users wanted to take a trade opposite to the direction the agent suggested, and that's why we made it possible. Um, yeah, that was the reasoning behind it. And yeah, we are continuously adding more agents, making the agent creation interface more usable by everyone, and make sure for users it's more like copy trading with an agent. The thing with agents is you can see their past record, see how well they have done, and choose accordingly. Whereas whenever you follow Telegram groups or someone's trades or Instagram, or even if you follow their wallets, every user has like hundreds of wallets, and whenever they are taking a trade in one wallet, they might be taking an opposite position in the other one, and you would never know that, and you would end up following one of the wallets, and yeah, that isn't good for you. But in case of agents, they manage their portfolio, and you can follow the best ones, and the ones that are not doing well just die out, and new agents come in. So it's the best way to trade, and we have seen the numbers. uh, Hey,
And yeah,
Hey,
hi
hey
Zaki,
man, how
our
are you?
guest is here. Welcome. So maybe we should start with, like a little bit of background, Zaki, and then introduction, and then we continue from there. We are live at this time.
Yeah.
All right.
Okay. Yeah, Zaki, it would be great if you could tell us a bit about yourself. I mean, I've followed you a lot on Twitter, but just a
yeah,
bit of
okay.
background.
So my name's Zucky. I am a sort of long time builder of things. Have been before crypto. I used to do biotech things. I'm doing some biotech things again.
Nice.
I got started in sort of. I did a bunch of I did a bunch of different blockchain things, a bunch of different cryptography things. Then I was very involved in launching the Cosmos ecosystem,
Mhm.
and did all of that stuff. I do Zcash stuff, but uh, I my interest in AI has historically been was not super large.
Mhm.
I didn't believe until like 2023.
Mhm.
That that machine learning, the current set of learning techniques were going to scale
Mhm.
as well as they did. But now I'm a ASI 2028 kind of person at this point.
Nice.
So you gotta get interested in this stuff, start
Mhm.
learning. I've been doing a bunch of different AI things recently.
Mhm.
So we just announced last week that we're sort of rebuild. So started this protocol called Sommelier Finance in 2021.
Mhm.
Sommelier was basically one of the early vault concepts. We had we had a Cosmos network that connected curators with vaults on Ethereum.
Mhm.
And that we thought that was kind of the model back then. And and now it's become a very popular model. But I'm actually very skeptical that this model is going to be the model going forward. I think the model going forward for finance is very much AI that manages your money and AI that composes all the different things that you have as a portfolio of solutions for managing your money. And then I work on a bunch of stuff in the Near ecosystem that's related to AI. So I have been a big contributor to Ironclaw, which is Near's agent framework. And then I'm working on this thing called Trace Commons with the Near ecosystem. And Trace Commons is we can get more into it, but basically the idea is agent traces have become a very valuable commodity, it seems, or have become a very valuable commodity. A trace is basically when you use an AI to do any task, it's what did you prompt the AI with, and like what was the context that you fed into it. Then what did the AI, what was the plan it came up with? What were the tool calls? What were all the things to respond to the plan? And then all of the steering and correction that you gave it along the way. And then, basically if it got to a successful end or failure. And I think you see lots of evidence that traces are an incredibly valuable thing for where we sort of are in the development of AI. And so Trace Commons is this idea of building sort of a place where people can share their traces and sort of get a piece of the monetization of those traces. So we're working on that in the Near ecosystem. And I've also, Ilya and I are writing a distributed pre-training and post-training framework. I don't know. So I do lots of AI stuff now.
Oh, that's a lot. So for our listeners, the trace data is useful because when in the initial models of AI, you used to give it a goal, like a particular question, and I expect this kind of answer. But as the tasks get more difficult, just that is not enough. A task involves multiple steps.
There's like a deeper reason, right? Which is, so, the initial, LLM breakthrough was, okay, we have, the scaling hypothesis, of 2022, 2023 proved out, which is if you have more tokens to train on, and then you have bigger models, you are going to get emergent new capabilities. And so there were all these, sort of hints of AI, but if you were like, hey, if you remember back to 2023, 2024 era models, they could autocomplete writing code for you. Sometimes it was genius. Sometimes it was terrible. It could help you in a lot of little ways, but it could not string together the actions to perform a task. And then O1 came out from OpenAI, and R1 came out from DeepSeek, and everything changed. If you were paying close attention Christmas time in December of 2024, you're like, I mean, for me, I was like, okay, Singularity's here. All right, we're like, Foom is happening. And every last 2 years they've been living in Foom. But we have this problem right now, which is AIs can do a lot of useful work, but the problem, the training methodology that OpenAI and DeepSeek sort of pioneered, and DeepSeek published and open sourced a lot about how they were doing this, and then that has gone everywhere and improved, is basically you have a task, and then you want to be able to, you need to run it in an environment where the machine can be like, okay, I have this task. Let me try one small deviation. Is this better or worse? Let me try another small deviation, better or worse. Let me try a small deviation, better or worse. And in order to create those environments, you need large data sets of people doing real work. And math and software engineering became the first two things that you have these data sets of people doing real work.
Yep.
And this is why you have seen, like why we're sort of, we're like very close to AGI, ASI in math these days. There's the Jacobian conjecture big thing that happened. And so, and like that was all seeded by like lots of data on the internet. Now we're in this world of
just to add there, it wasn't just from the internet, it was reinforcement learning environments. The agent generated traces on its own, and there were verifiers in place to check if each of those states are correct and those outputs are correct, and then it can go to the next one.
Yep. Yeah. So okay, yes. So exactly. And like, where did these things come from? So it's like traces. So like you have two things. You have reinforcement learning environments, RL environments. You have traces, which sort of seed these environments with data. And then you're able to, from these two things and, millions of hours of compute, create these AIs that are, approaching and potentially exceeding human capability across a wide variety of tasks. And so, and in general, like trace data is very locked up today. Like, essentially, this is like one reason of thinking about like why are the subsidies on your Claude subscriptions, your OpenAI Codex subscriptions, why are they subsidizing inference so much for you? Well, one of the things they're getting a value while you do this is they're getting tons of traces to make the next generation of models better, and you just see the rate of new model, incremental new model releases just is going continues to accelerate, and that all makes sense. But I think there should be a world in which people can get more from the value that they're producing with their traces than just a better model. So yeah, and I think like one of the biggest research questions in AI right now is sample efficiency, because humans are just amazingly sample efficient. A human learns to drive a car with sometimes with 20 or 30 hours of exposure. A human learns to drive a car. The AI becomes a superhumanly good driver, but it needs millions of hours of driving data to be trained on its, and so you're like, okay, what can we learn from this? So like right now during this, sample inefficient era of learning, there's just, immense economic demand for these traces. And so we're, what things I'm trying to work into Trace Commons is like, this idea of scoring traces, right? So like a bunch of traces that are like kind of over-represented in the data, in training day to day, like make me a website with like a Python backend is like not really that valuable. But, if you have a trace that's, solving a complex business problem, these kinds of things, working on something, a novel technical problem, and you get a lot of interaction between a skilled human and the data and the LLM outputs. Like there's a tremendous value that's being created. So how do you build a system for doing that? Lots of interesting problems.
Definitely.
But yeah, I mean, the other thing that is kind of interesting and surprising is just like, if you've been doing like high performance blockchain infrastructure and cryptography, machine learning is like not that far from either of these things. They're weirdly, there's a lot of overlap.
Would you like explain that a bit more?
So, I mean, in general, I'll put this way. There's like there's a couple of things. One is, cryptography is largely a field of just transforming like large numbers, basically. Um,
Mhm.
and
Yeah, you would say that.
and like especially when you're doing zero knowledge proofs, all of the stuff, it's just transforming a
Mhm.
large number of large numbers quickly.
Mhm.
Um, and the transformations themselves are pretty simple, but it's just the size of the numbers and the amount of large numbers that you need to transform have always been the challenge. Um, what is an AI? It's just, a trillion floating point numbers and then transformations on them.
Yeah.
Um, and the transformations are pretty simple. But
Mhm.
then what is the work? The work is bottlenecks. And when I started started in blockchains. Blockchain performance was like, 8 transactions per second. Now, we can make 100,000 transaction per second blockchain if we want
Mhm.
to, pretty much on demand. So all of how to do it is so like what was the last 10 years of work doing that? The last 10 years of work was like identifying bottlenecks, figuring out in industry. So
Mhm.
also all modern machine learning is doesn't fit in. So in cryptocurrency, we have to divide all of the work among many computers because that's where you get the interesting
Mhm.
properties of cryptocurrency, which is you get this like censorship resistance and non-repudiatability. So basically, if you send a thing, if you sign a transaction and put it on a cryptocurrency network, you can't undo this transaction. And
Mhm.
this is like the thing from which, and then
Yeah.
if you want to send a transaction to a cryptocurrency network, it's very difficult for anyone to stop you. These are the interesting properties.
Mhm.
And the
Mhm.
way you get these interesting properties is by distributing work over computers all over the internet. This is the way you get these interesting properties.
Mhm.
On
Yeah.
for machine learning, we have 2 problems. One is the size of these models and the amount of
Mhm.
data you have to process to pre-train and post-train these models could not be done on any
Yep.
one computer. Right? If you need to have if you need many millions of hours of compute times to do this, if you ran it on a
Mhm.
computer, we would get a model release every few million years. So it would be very annoying.
Yeah.
So how do we solve this? You parallelize the work over you divide the work over many machines, and then you have ways of merging and combining the work. And the algorithms for doing this are shockingly simple. But like there's and it's just amazing how well they work. But then you can
Mhm.
and like if you're like it's like if you've ever done anything in sort of cryptography, you're like, oh, okay, it's like this computer does a bunch of work, then it like has a bunch of it has this giant list of floating point numbers, and it needs to find a compact representation of those floating point numbers that preserves the essential
Mhm.
properties, and then share it with a bunch of other machines that are also doing similar kinds of work. Then you have to figure out how to divide up the work among all the machines, and then you got to optimize for all the things about like so you don't have to copy data between GPUs. And then the other problem, which is a thing that cryptocurrency people are sort of very familiar with, is just scarcity,
Mhm.
which is so in cryptocurrency world, we have digital scarcity, but we also have scarcity of compute resources. Compute resources that cost real money.
Mhm.
And so, like, how do you allocate efficiently over in this complex environment? So we do that.
Yeah, definitely. So would you say like you touched upon your work on traces? Would you call it imitation learning, where users are sharing their traces and AI is learning from the path of how a work was done to actually being able to repeat that work and in a more generalized manner?
I mean, what all of my understanding of all the academic research is it's not, I mean, so, okay, I mean, I am not remotely an expert on any of this. So this is just like Zaki's internalized representation
Yeah.
of what the hell is going on.
Mhm.
I'm sure people on the internet know more about this than me. So like my internal representation of this world, of what's going on, is basically um, what people typically call imitation learning on one hand is like more like that super sample efficient learning that humans are able to do, where we see something only a few times and then we're able to kind of learn to mimic it, and then generalize from doing that. And like machine learning doesn't know how to do this yet. And then you have this, but we have this other thing, which is this sort of trial and error learning in this environment with some sort of supervisor or teacher.
Yeah. Judge, suppose. Yeah.
And that thing has this really cool property of generalization, right? Like it's not just, oh, I got exactly the same input. You know, someone gave me the same prompt that I saw once in, one of the data. It's more like if I give you millions of prompts from millions of users and all of the corrections there, I can like generalize some sort of understanding that helps me take care of all tasks of this kind. It's like you are, if you see the process of a human being going through and creating a mathematical proof, validating that proof, getting it wrong, getting it right, that workflow, and I try it, a million times, and I learn over a million things. The machine learns something about, proofs. It learns something about doing just even this kind of, generally this kind of procedural work. It's very cool. So it's really cool. Like, I can't believe all this works.
Yeah. So I was talking more in terms of imitation learning as it's defined in ML literature. So when they talked about imitation learning there, it's more about, so in normal supervised learning, you give an input and an output. So input could be images and output could be what's there in those images. And if you give millions of those images, the model will learn to identify things in the image.
Yeah.
Then there's in reinforcement learning, there's an environment. Your actor takes some actions, gets some rewards, and it learns what is the best path to reach to a particular reward. So there you need an environment and a judge or a supervisor. In imitation learning, you have previous traces from humans on how to do things, and you just show them that. So like the positive path, and the agent learns just from that. So it's like how it's kind of how Tesla trained their self-driving cars, where they had traces of how humans were driving the car, and they just fed it directly, and the model learned from there. So it is more efficient in a way that in reinforcement learning environments, you have to generate lots and lots of traces and get feedback on each of them. And the supervisor has to be really good, because
from what we've been talking to, we've been trying to learn a little bit. So we are a little bit in the dark because we know that there's demand for these traces, but we don't know, and we know that there are people like Mercor has built this whole business right around where sometimes you pay lawyers and investment bankers and doctors and stuff like this hundreds of thousands of dollars a year basically just to generate traces. But I think it's interesting because my impression of the world is that there's actually like a lot of different things that the trace data is transformed into before it is deployed into the learning environment. So I think that there's a lot of different, I think that the trace data is like, I don't think there's like a linear, like trace data goes in, you run an algorithm on the trace data, and then that algorithm on the trace data outputs a better model. I think that there's more.
I think you'll need sort of a question and an answer kind of format. So if there's a trace, you have to generate a question as to what it is you're expecting out of that trace, or why you should do that. And then the answer can be that trace. Okay, I need to search I need to open that, and then the agent will the model will learn that.
Yep.
Okay, so you touched upon vaults a bit, that you don't think this is how it's going to be in the future. It's going to be agents managing capital. How do you say something like agentic vaults could look like, and how would that be different from the vaults we have currently?
Yeah. Okay. So why did we build vaults? So DeFi, sort of 2021 onward era DeFi. One of the things that we observed, two things. We observed one thing was there were a lot of profitable things to do in DeFi that had effectively no user interface. If you could not write your own Solidity contracts, it was really hard for you to access these opportunities. The second thing that you needed was like 24/7 monitoring. So our solution was like, how do you have essentially professionals do this for you? And then the third thing was, blockchain scalability was in a bad state. And it was gas prices, right? Like it was very expensive to make transactions. So if you had like a smallish portfolio, $1,000-ish portfolio, all of your benefits from executing complex DeFi strategies would be eliminated by all of your profits would just eaten up by transaction fees. Okay, so let's come back to this world now. So in this world, so gas prices. Well, we can do the same order. Okay, so you have these complex transactions like looping. Looping is basically where you take an asset, you borrow against the asset for something that earns a higher yield. Then you deposit that higher earning asset as collateral, and you borrow again. You borrow the underlying asset again, and you deposit as collateral. So you have this. So basically, it's a form of crypto native leverage, and it composes things that we've gotten to work really well in crypto, which is decentralized exchanges and money markets, which are two economic primitives that we've really, and it's always been a very popular thing. So one of the things that we wanted to be able to do, so this is just an example. So if you want to do looping, though, the sort of most efficient way of doing these loops is you borrow, you deposit collateral, you take flash loans, which are these DeFi instruments where you take a loan that only exists for the length of one transaction or one block, and you pay back at that, and you essentially execute this loop rather than iteratively over many blocks. You do the whole thing one block with this like cheaply sourced capital and adequate amounts of decentralized exchange liquidity. But there's no button, there's no website you could go to and be like, click the loop button and it does this. You need something that can like go and look at spreads on dexes and interest rates interest rates on collateral and on money markets, and make sure all of this stuff is like done in a way that makes sense. You need like a bunch of things, run simulators, all of this stuff. It was it was pretty annoying to do. And we started doing experiments with this to see if AI could do this sort of all through 2025. And basically when Opus 4.5 came out, I was like, holy shit, it does it. Like it constructs the transaction correctly. Like you give it the right things in the context window and it will make the right transaction. So that was like, almost, that's almost a year ago. That we've had it and that we've had the capability for doing this. Now, I think taking that latent capabilities, the models, I I think most people who had this moment with when Opus first, and they're like, oh, the models like know how to use Cosmos, they know how to use Ethereum. If you make it, you want it to send a transaction for you, it will get the answer right mostly. Now, like turning all this stuff into products, people have it's been a bunch of work, a lot of startup companies formed, all of the stuff. But basically, we've been getting there. So like this thing where you're like, oh, where like there are these profitable things to do on chain, but like there's no user interface, and you need some dynamic ability to judge the situation in order to execute this, which is why no one could ever build. People are so unsuccessful at building UIs to give this. So now AIs do that. The next thing you want is a world in which, sometimes things will happen in DeFi that like where you have to dynamically respond to market conditions, either slowly or quickly. You might find yourself in a position, you have multiple instances with these like looping positions where suddenly the looping position becomes unprofitable because of changes in conditions. So you want to have something that is like monitoring liquidity on dexes for how do you exit this position. It's monitoring interest rates, and it's sort of dynamically deciding whether or not to go in and out of a position. You do that. And we're again, that's what you wanted professionals to do. Professionals have done varying levels of good job for this. But this is actually a great task for an AI agent. An AI agent can just ingest the data on a regular basis, look at risk. I think it's still like a really open question today about the AI agents that we have commonly available for consumers and how good they are at managing risk. That's probably still like I think one of the biggest open questions. And a thing that we're going to have to is a capability that we're going to have to still figure out with these machines. I don't think that there's like a lot of good pre or post training data on risk that's in the data sets today. But you could do a decent job.
Yeah.
You can do a decent job with this, and it's something that will certainly improve. So the risk thing, I think, is still early days of taking humans out of the loop there, but improving. But that will improve. And then the last thing is just transaction fees. And the reality of the situation is even Ethereum mainnet has now become cheap enough, and with the scalability that what's currently on the roadmap in terms of what future expectations, and like sort of what the competitive dynamics among blockchains are, there's no reason to believe that Ethereum will not be. Ethereum is just still a dominant source of yield, though Base and Arbitrum. And it looks like Robinhood Chain have become like pretty big competitors. Solana also is getting more and more things like this, more and more infrastructure like this. So, given all of those environments, it's just like it was like ETH mainnet was biggest place to generate yield and store your assets, but also the most expensive. I think $1,000 portfolios are profitable today on Ethereum, and I think they will be for the foreseeable, into the expected future. And I don't think we're gonna end up anymore in a world. So those three things that sort of drove. So now what I think will replace vaults. And then on the other hand, you also have this other piece where it's like vaults. When you built the vault, you had to pre-curate what you were going to compose with. You had to be like, we compose with Uniswap, or Aave, these Aave markets, all of this stuff, and then to make it safe, we built this whole governance system. And you either have people YOLOing your money into whatever, or you have a governance system that controls, what money goes where and why, and like what things compose. This doesn't seem like actually to me what the world looks like for most users in the future. In the future, I think what you compose with should be very personal to you. So And like, it doesn't just mean that you can, and that means a world where you aren't just composing with sort of on-chain things. But you can have your AI agent can just as easily be like, oh, like your money, like this money, like you sold this crypto asset, now you have stable coins. Maybe it's you're earning yield on Robinhood or Coinbase or other things. Or maybe it earns yield on Aave. And it like, look at risk and figure this out in a personalized way, but it has my Robinhood key API keys, it has my Coinbase API keys, it has a smart wallet delegated capability, and all of these things are combined together. And like you could just, the AI agent can just decide where your money should be. And you'll tell things like, oh, I need $10,000 of cash to pay bills this month. Okay.
Yeah, so I definitely agree with that. And one of the reasons is all of these things are pretty objective. And AI is really good at objective stuff. When you have the goals well defined, you have a reward function that I have to maximize my yield or maximize my capital in, say, a specific duration of time. All the interest rates are pretty well known. And you have also historical data as to how they have changed and how they are supposed to change in due time. You can look at the chain data. So it doesn't feel that difficult. Like there are some levers there based on what user is interested in, what's their risk threshold, and so on. But shouldn't be that difficult for agents to do, especially for such an objective problem. And we have coding, for example. In programming, agents do well because everything is well structured, and you can always run the code and see how it's working, and is it doing the same thing that you expected it to do. So why don't you think we have that adoption yet, where everyone is managing their capital in DeFi through their own agent?
So there's the security problem with agents is annoying, because the biggest problem with agents right now is prompt injection. And so prompt injection is basically this idea that you have an agent, it's connected to the internet, it's able to go look things up, it's able to, but agents are very vulnerable to basically reading something, and that reading thing causes them to change essentially their intentions, their goals.
Yeah, the new version of SQL injection, which we used to have.
Yeah, and this is a pretty pervasive problem towards the idea of agents that use money, have control over things, all of this stuff. And we are I think everyone in the AI space is like, how do we solve this problem? And the blockchain people have their own sort of particular little flavor of solving this problem. And there's not, humans are prompt injectable. Humans get prompt injected all the time. Like, this is what advertising is. If you've seen a magic trick, you're just prompt injecting people.
I mean, the whole of marketing is based on that. So.
All of marketing is prompt injection, right? Fraud is prompt injection. Like, you just get prompt injected all the time. It's not like, our brains have, billions of years of our whole system is has had billions of years of adversarial input to evolve against. But is not perfectly robust, and our AIs are orders of magnitude worse. So we have to build these systems in which either there's a human in a loop, or but then the question is, we've had this like thing that in cryptocurrency we call the blind signing problem, which is how do you know the thing that you signed is the thing that you wanted to sign? And that was a world in which you visit a website. Maybe the website got subverted, but hopefully didn't. And then that website was run by a person who put the transaction together. And we're like, hey, how do we know this is real? So we have this is a thing
that's not a problem with agents, right? They can interact directly.
No, it's a problem pervasively. But the problem is agents make it much worse.
Oh,
this is the problem. So because the problem is so if you look at the transaction supply chain of the sort of pre-agentic world of DeFi, the world was, I go to this website, the website reads the blockchain, reading state from the blockchain, the website trusts a bunch of contract addresses and entry points and whatnot, and then that software brings you to the user, and you're like, surfaces a transaction that you then see in your wallet, and you see in your hardware wallet, and then you execute. The when you are in this world of agentic finance, okay, the agent got the transaction that it wants to execute from somewhere, right? Like the contract addresses came from somewhere, right? Like it decided that these are the right contract addresses and this is the right inputs to sign. And then it's like, okay, like sign it. Now you have like kind of no idea, right? Like you're like, okay, what was the supply chain of this? And so either we got to like figure out a solution to this problem. And this is, I think, is the solution. So either you have some sort of system that could be on-chain smart contracts, like this is what Agoric has been building, or there's various teams, or you have some off-chain system that is like confining the AI in such a way, and then what you want is this like what I call is what you see is what you sign, where because like the AI could be saying, oh, you're depositing into Aave, but like it could just be someone prompt injected the AI to send your money to North Korea, right? And so you have to build a system that will go in and say, okay, like the AI is saying this is a deposit to Aave. I went and simulated this transaction. It sure looks like this is a deposit to Aave, and it's going through, sort of a known Aave sort of supply chain. And this is like the real problem of agentic finance, especially on-chain agentic finance. So it's like, it's a simpler world if everything is constrained to Robinhood. Like you could prompt inject your agent to be like, buy, this stock, but like it actually buys a different stock. But like less of a giant problem space, but where it was like, if you're on chain, you can prompt inject your agent to do anything. So that's like one thing that like, different companies that I have been working with have been trying to find solutions to. So like, I think like the short answer is we're going to have a lot of on-chain finance is going to really start happening now, but with smaller amounts of money. I think we're in the, and then there's like a lot of cool stuff that is kind of starting to hit that is going to make this problem tractable. It's not like an unsolvable problem. It was like, it's like, if you just give an agent, money and you say roam the internet and make, trade with it and, interact on chain with it and just send transactions as you think, that agent will have $0 very quickly.
Oh yeah, definitely. Yeah, but isn't it better to like start with something simple where only user has access to the agent, like in a way only they can send message to that agent, so there's no chance of direct prompt injection.
It's just not very useful.
No, so only user can send ask you agent what to do, but agent has access to on-chain contracts, maybe in some limited way. Like there's like probably 1,000 contracts that drive like probably 80% of the value.
But it kind of needs to, it needs to have access to like sort of like, what are the money market funds, all this stuff. And like ideally the ideal world is like sort of new opportunity discovery can happen sort of in a fairly autonomous way. And like it can sort of feedback risk profiles. So then you do want it to be able to like search the internet and search social media and see what people are talking about on Twitter and stuff like that. But then so the reality is like many people built the simpler product that you are talking about and is not hit product market. It's like
you have to have some, you have to have some restriction to for safety, but if you make it too restricted, then there's not enough to do. So
there's not enough utility, right? Like, I think this has been the problem. Is like, how do you simultaneously have, because the future I like I said, I am 100% convinced the future is agentic finance. It's like, how do you have enough capability that it's a really compelling system for you to use, that like you would rather use this than your wallet? And I have not, I've not seen an agentic wallet from the previous generation of wallets that is like, it's sort of this tricky thing. You're like, oh, all this has is like, the super safe DeFi stuff. Like it has, this set of Uniswap things, this set of Aave things, this set of, other, restricted subset of Morpho things, like all of this stuff. And you're like, okay, great. Then you ask anyone to use this, and you're like, is this really that much better than just clicking on these things? Like clicking is normal, and like everything works, and the flows are mature. You're like, great. Okay, not that great. What you really want is, you're like, what I suspect what people really want is, is more like, hey, like, tell me if there's like a new opportunity on Morpho, on some random ass, on Monad, that like on like some Morpho market on Monad suddenly has high yields, or some market on Mega ETH or whatnot seems to be outputting high yield. What are the risks? What are the cost benefit of YOLOing into this? Give me some analysis, story about that. The second thing is, it's like, hey, like, I trust Aave v3 across like X number of chains. Just, if it makes sense to reallocate funds between those chains, just do it. And I think, but if you think about what that just doing it means, now I have to have strung together not just a one-chain solution, but a cross-chain solution where, money can move from one chain to another, but the AI cannot send the money to the moon or into the void. Tricky things to put the complexity surface of there is non-trivial. But like, yeah, I just generally think people are getting closer and closer to it. But it's a lot of people, a lot of people got very excited in October last year about, the fact that this stuff is actually working. And we're like, hey, let's just build the simple thing. And then, many people built the simple thing, Wayfinder, Bit, all these things. It was not enough for people to start doing this. And, I think the like total funds managed fully by on-chain agents right now is in like, hundreds of thousands of dollars right now. It's not even millions of dollars. I just, because I think there's like this, there's some minimum threshold of capability before everything starts to shift. I think it was just the same thing we saw with coding agents, right? It was like, early adopters used Cursor, early adopters used Claude Code. It didn't really work, and it worked. And the biggest thing with these capabilities, right, is like when the first couple interactions are like great, but then as you kind of go down into more complexity, the whole thing falls apart. That was like coding agents in early 2020, like sort of spring and summer of 2025, because I was doing a lot of experimentation. I was like, like I see where this thing is going. I see what happened with O1 and R1. Like, I know that this thing will eventually work, so I might as well start figuring this out now. But like, it was like, okay, like I have this piece of software. It's like, seems to be making progress, seems to be making progress, and now this thing will just like melt below my fingers without.
Yeah, definitely. So we are almost out of time, so let's move on to our next segment, rapid fire.
All right. So these are like, some of them are personal, short and sweet questions. So one of them, like everybody's wondering about, is there some task you guys never use without AI? Like you always use only AI with?
I mean, software engineering work. My favorite new thing is making like little marketing and go to like launch videos and explainer videos with like Claude Design and Fable. I think that's probably, but yeah, I mean, I don't know. There's like so many, like you just keep iteratively expanding the number of things you want to do with AI until it's everything in your life.
All right.
Just somewhere on that curve.
Yeah, I mean, programming, definitely. I haven't written a line of code in some time, but I do try to like write things myself just so that the muscle doesn't atrophy and it has more personalized feeling. But yeah, I would like to automate as much as I could.
Okay, so how about on the other side of the spectrum? Is there some task that you will not trust AI agent to use at this stage? Not in the future, AI will be better, but like right now.
Well, I mean, AIs are still terrible just writing. Like that's just the thing that they're worst at. Um, but I think blockchain transactions within rate limits it does a good job.
Okay, Shashank?
Yeah, probably recommendations, because it tends to end up on averages, and averages aren't really good recommendations.
True.
Yeah. Okay.
Okay, so you guys spoke a little bit about prompt injections, and humans can prompt inject AI agents, but do you think that soon, or maybe in the medium future, we'll have situations where it's the AI agents prompt injecting the humans? Like suggestions, Pavlovian manipulations, and all that. Maybe keep interactions, whatever.
I mean, I do think that like all of these fraudulent phone calls and everything, there's definitely some AI element, AI prompt injecting humans at this point. But I think one of the things that's really scary is I do think as we get into the like ASI world, like I do think that AI will become superhuman at manipulating humans. Like, I don't see any
Mhm.
reason it wouldn't happen. Right now, we have this asymmetric advantage of several billion years of adversarial inputs is encoded into our system in some way,
Mhm.
whereas AIs just aren't really exposed to that kind of adversary. And in LLMs, like we have this pre-training system, this post-training system of reinforcement learning. But as we saw with sort of Alpha Zero and stuff like that, adversarial self-play is like one of the missing pieces and we don't have that really working at scale for LLMs yet. But yeah, and we're, people are making I saw like this arena for like sort of human social games.
Mhm.
There's a adversarial component. And the AIs do terrible at them today, but like again, I expect them to be superhuman eventually, and they will be superhuman at prompt injecting.
Yeah, I would say the world would be like the adversarial reinforcement learning environment for the agent. So you can just run like hundreds of those ASI agents trying to scam people, and some of them will succeed, and they'll learn more and become better. And same on the other side, the good side. You can have agents trying to save people, and some of them will learn and become better.
All right. So talking about experiments, what's the most unusual agentic experiment you guys run? That could be to test an agent's capabilities, or like something completely out of left field.
Yeah, I would say our my pipeline of generating our portfolio management agents. It's there's like an agent about signals, which is like try to predict things like better than random, and try not to overfit. Those are quant models. Then there's another one who tries to like generate strategies based on those signals. Make sure the assets, the strategies are not too correlated with each other. So yeah, there's this whole thing where hundreds of agents get generated, and we rerun them, see what kind of things are doing well, and it's also like genetic algorithms where good traits get passed on, and so on. So it's not about one agent; it's about that system which is generating and improving those agents over time.
I
Okay.
think that this idea that as developers we need to have like high quality evals for everything for
Hmm.
what we're doing is actually probably pretty spot on. Um,
Yeah.
we have this thing called attack bench for Ironclaw, which is like an eval of our security model, and
Hmm.
generally usable. And it's one of the cooler things that the Ironclaw like sort of team has been building. Um, but I also feel as a developer, it's like actually one of the hardest things to build is a good eval right now.
Yeah.
And we know that the labs are struggling with this too, like that, they use the evals for so much for building, evaluating, training their models, but there are also things that like, why do we use evals are like pathologically broken. Um, so yeah, it seems like a thing that we're all learning together though, how to do a better job of.
Okay.
Um, Yeah. So I would say
It
it's
was
more like
easier when the LLMs were stupider to like evaluate them.
yeah. So I would say it's more like a difference between science and engineering. So in science, you'll always assume a perfect eval that can give you all like the good results. In practice, you'll probably have to like have 10 evals to kind of fit that the eval you're trying to get towards. And over time, as you generate more samples, you'll probably overfit those evals and have something that doesn't work as intended. Then you'll end up having more evals. So it's kind of not a solvable problem, but you tend to improve over time.
Okay, so we have only a couple questions left, and I hope this one does not generate PTSD. So, what's the most expensive lesson you guys had in crypto, and does it translate to AI? Like, it will avoid you to make the same mistake.
Oh, my Telegram got hacked at one point, and like I didn't even do anything. I didn't even download. I don't know how it happened. Maybe public Wi-Fi. Probably connected once during one of the conferences. Yeah, a lot of hassle. The Telegram help is totally non-existent, so you have to create a new account and then connect with old people, and yeah, it's difficult.
Yeah.
I think so. I think like basically one of the things that we've been dealing with in crypto for a long time is just there was like pre-crypto software and then there was crypto software, which is almost like extraordinarily more adversarial environment than all of pre-crypto software. Way more adversaries. And learning to live with and survive, and I've been in incident response on so many multi-billion-dollar incidents in my life. But I do think that AI is, as we're seeing right now in sort of the cybersecurity apocalypse that we're currently in, where, lots of software that, had been around for a long time, Cosmos has seen a lot of this getting exploited. There was the, there was the soundness vulnerability. And so, but it's basically right now, I think we're like software that is exposed to arbitrary external input I think a lot of it is just going to have to be formally verified. I do think that we're entering, and Zcash's Ironwood upgrade is like, to me, I think the most profound sort of what does blockchain do to AI? So on one hand, we had Opus 4.8 find this soundness vulnerability that has been in Zcash for more than 6 years, and many of the world's best cryptographers have all looked at it. Now, it was actually like kind of very simple oversight that caused the vulnerability. And, you would think that, but no one found it. On the other hand, Ironwood is like, take the Zcash code and like, people have looked into this question of formally verifying the Zcash code pre-AI. And it's like $10 million, multi-year project, absolute state of the art, and like frankly, none of the Zcash artists had the money to invest. So we lived with this for so long. Formally verifying the Zcash code has been in this current age of AI was a 1 month project, cost under $1 million, and it's done in 3 weeks. And so I think that the like reality of the situation is we quickly get into this world where like nothing that isn't formally verified should be shipped.
Yeah, makes sense. So talking about these types of agents, we close with maybe this is a personal one. So what's the first agent that you either built or experimented with that you were super satisfied with?
I have a code review agent that has been extremely satisfying for me. I have lots of people who, a lot of people who, a lot of projects I contribute. Like I think one of the utility that I have is Zucky's code review agent. Has been a huge success. And then it's cool to have these like sort of private interactive agents that you've sort of been evolving in combination, and as models get better and continue to seem to have sort of unique characteristics that make them valuable. So I've seen that. We did a lot of experimentation with sort of like Twitter agents last year, and that was all incredibly unsatisfying.
Yeah, I mean, in my case, it would be our UI UX design agent. So, like, it has access to several skills, and we also feed it our data from our platform from time to time, how users are doing, where users are facing issues, which are the screens where users usually drop, and it comes up with some great recommendations and super helpful. If we had to go through that data ourselves, it would have taken so long, but it's so good at it.
Yeah, it's so sleek. And so with this, we arrive to the end of the hour. Thank you so much for your time, Zaki. Thank you so much, Shashank. Please follow our guest, Zmanian at X, and also Iqlusion. And before we go, just want to say that we have a tournament, 10K paper trading tournament. Stay tuned. And thank you all for joining.
Yeah, thanks a
Nice
lot.
to meet you guys.
Yeah.
Nice to meet you. Bye, everyone. And the stream has ended.